Today is Thursday, August 30th. Okay, so polynomials. The things that I'm trying to talk to you guys about polynomials today, there's three main things you really need to know. One, end behavior. You need to know how to find end behavior. What justifies our end behavior? The degree and the leading coefficient, right? Those two items dictate our end behavior, correct? We also need to know our zeros today. Okay, so we'll have a polynomial and we're going to find our zeros. How did we find zeros? Well, Jaden, we did we factored if it was a quadratic. We also factored trinomials by factoring by grouping, didn't we? Okay, which you're going to use that skill today. Or we did quadratic formula, right? Those are the ways that we did. We need to find those zeros. Okay, and with those zeros, our end behavior, we can go ahead and graph a sketch. We're going to sketch things today. We're not going to get a full graph because I don't care about the full graph. I want to know, do you know the end behavior of this? How does that affect what the graph looks like? Do you know the zeros? And the other word that's today that you're going to learn is what we call multiplicity. Okay, and we'll start with this. All right, so if I started with y equals x cubed, okay, we all should know basically what that parent function looks like. It looks like that. Would you guys agree with me? If I plugged in -1, I get -1. Plug in -2, I get -8. It's growing really quickly, isn't it? -3 is -27. 3 is 27, and so forth, right? Okay, what is the value that makes that equation 0? Say again, I'm sorry. What's the value that makes this equation 0? 0, right? And notice on our graph, it's crossing our x-axis at 0, isn't it? Now, there is a rule, I don't know if you've ever heard of it, it's called the fundamental theorem of algebra. Fundamental theorem of algebra. And what that says is looking at your degree, that tells us the number of zeros there are. So I see x cubed. How many zeros should there be? 3. But how many zeros did I just say? 1. It was 0, huh? How does that become 3? Well, to be honest with you guys, isn't this x by x by x? And no, it's not a bad movie. Okay? Don't think that way. But there's 3 zeros there, isn't it? All zeros there are what though? 0. Notice there's all 3 zeros. 1, 2, 3. Each of those gives me a 0 of 0. So what are my zeros? 0, but it gives me a multiplicity. That means there are 3 of them. Multiplicity tells me how many zeros are at that specific point. Okay? Does that make sense what I'm saying? So in this case, it's x cubed. So therefore, I have 3 zeros at 0 for all of them. Okay? So multiplicity tells me how many zeros are located at that specific 0. I know that's saying a lot of things. Okay? Let's do one that doesn't quite have 0 in it so many times. Okay? Let's bring it down right there. Give me 1 second. I'm going to finish this and I'll let you ask that question. Is that okay? So I'm going to do x minus 1 cubed. What's the value that makes this equation 0? 1. Does everybody agree with me on 1? Basically, it takes that last graph that I just did and shifts it to the right one. Would you guys agree with that? You guys remember learning that from last year? Shifting our graph to the right one. And that makes sense because what's 1 minus 1? 0. How many times is that happening? 3 times. So what is my multiplicity on the 0 of 1? 3. Okay? Multiplicity. So I'm going to write one really quick, see if you guys can just tell me my multiplicities. I'm not going to do anything yet because I haven't explained it all the way. one of them is 1. That's my 0, right? That's from this guy. What makes this guy 0? 0. So this time I have 2 zeros, don't I? You guys agree? What's the multiplicity on this 0? 2. I have 2 of them here, don't I? Right? Hence the x squared, because I could write that as x, right? Hence there's 2 zeros happening at 0, but really I only have to write it once, don't I? So do you guys understand technically it's 2 times it's at 0, hence the squared? How many zeros are at 1? 1. Okay, so total I have a total of how many zeros? 3. Even though there's only 2 showing, okay, that's how you're like, oh, look at this. That's how that looks. There's 3 total zeros because twice or 2 of them are at 0. One of them is at 1. So how many total zeros do I have? 3. So what degree is this? This is the 3rd degree. Because once again, the degree always matches the number of zeros. Okay, hence the fundamental theorem of algebra. Let me come back to that first. If you had something beforehand. Go ahead, Jasmine. Do you need me to go back to the other part? Oh, fundamental theorem of algebra is no problem. Fundamental theorem of algebra is by looking at the degree of the polynomial, it tells us the number of zeros. So if I'm looking at this, if I distributed this through, would I not get x cubed minus x squared? Right? It's just already in factor form. Notice I have x to the 3rd, right? How many zeros should I have? 3. Did I get 3? Because this is equivalent to this, correct? Do I have 3 zeros? 0 has 2 of them, and 1 has 1 of them, so 2 plus 1 is. Okay. Now, do all those zeros always have to be real numbers? Okay, like x squared plus 1. It's really not that deep. X squared plus 1. If I found the zeros of that, there is plus and minus I. So would I actually have anything crossing our x-axis? No, because there's no real zeros, but is there zeros? Yes, how many zeros? Still 2, and I needed 2 because it was an x squared. See that, how that's working? Always has it. Fundamental theorem of algebra tells us that the degree equals the number of zeros. Okay? All right, so I would like to go here. This was awesome, but we'll come back to this guy in just 1 second. So we did this problem, we did this guy, right? We're going to go down some more. We're going to do this graph. Y equals x squared. What does he look like? He's a parabola. What's the 0? He's at 0, isn't he? Oh, that looks good enough, doesn't it? Okay. What's my zeros again? 0. How many of them are there? 2. Now notice, there's something I'd like to talk to you about. If we look at this previous one, okay, how many zeros are there? There's 1 real number as it, but it counts as 3 of them. Agreed? Notice it crossed 3. But if there was an even amount of zeros, what happened? It touched it and it bounced. We call those bounces. That's something we're going to write in our notes. Okay? If it is an even multiplicity, it will bounce. Okay? If it is an odd multiplicity, what's going to happen? It's going to cross. this is the big idea of the day. Okay. Okay, let's come back up to that x cubed graph. So if I come back up to that x cubed graph, that's the x squared, notice it's bouncing, meaning it came down, touched the 0, and it bounced right back up. Or, remember, what if it was negative x squared? Started out negative, hit the 0, bounced right back down to negative. Does that make sense what bouncing is? Okay? Now look at crossing. Notice at that 0, see how I have an odd multiplicity? Notice I went from a positive, hit the 0, and I crossed through, now I'm positive. Excuse me, I'm negative, hit the 0, now I'm positive. Does that answer your question? Is everybody there with me? Yes? Okay, so knowing this problem that we already looked at, ladies, are you okay? I can help you if you need to. All right. So, not that I just want to help, I'm not saying you guys can't talk to each other or anything like that. Okay, so I'm going to graph this really quickly. Where do I cross or hit the x-axis at? What's the two places? 0 and 1. One of my students in last class said, Mr. Roberts, can I cross the x-axis anywhere else besides those two spots on this graph? What do you guys think? Why? Or there'd be more zeros, wouldn't there? Right? Does that make sense what I'm saying? If it crossed somewhere else, that would mean it's a 0. So it can only touch or cross at these 2 points, can't it? And I don't know what's going to happen. But, what are the things that I asked you to remember? One, first off, I want to know my end behavior. Okay? How do I know, besides me foiling it through, because sometimes distributing it through is going to get pain in the butt. Okay, so I don't want to necessarily do that every time. By just looking at the top, how do I know it's x cubed? I have x squared, so there's 2 of them, right? X minus 1 for the first. 2 plus 1 is 3. Everybody with me there? So it's an x cubed. So x cubed, end behavior, boom, right? As I go to infinity, it should be going up. As I go to negative infinity, it should be going down. Yes? But we have to ask ourselves, that's only if our leading coefficient is positive, is it? Let me just ask you how I would do this. What does this come out to be? Positive. And then when I multiply it to this, it still comes out to be positive. With me? Okay. So does that change my end behavior than what our normal x cubed behavior is? No. Okay, here we go. We're going to graph it. But we'd also have another digit. If the x cubed after we would technically simplify and put it in polynomial form, because once again our leading coefficient would be in standard form of x cubed x squared. Do that regularly. Does that make sense to everybody? That's why I didn't care about the minus 1, because whoopity darn do, it doesn't matter. We're looking for the leading coefficient. Okay, so here we go. As we are over on the negative infinity, it should start down, huh? So we're coming from the bottom. Shake you like no other today. Woo! Okay. All right, we're to our first 0, which is 0. You guys agree? Now, looking at 0, that comes from this, the x squared, doesn't it? What's our multiplicity for 0? 2. Knowing that our multiplicity is 2, which is even, what should I be doing? I should end at that 0. So, now once again, is this an accurate graph? It's a sketch. Okay, so I touch this, I come back down. Now, I know I got to come back up here sooner or later, don't I? Because that means it does say it crosses there. I mean, not crosses. Why do I know it does cross? What's my multiplicity on that? 1, which is an odd number. Odd numbers cross at those points. Noticing going from a negative to a positive. Let's talk about it. Do we have the end behavior that I said that we needed? Okay. Do we have the zeros that were required of us? Did we use its multiplicities appropriately? Yeah. And that's how it came out to be that graph. Now, if you check that out, it'd be pretty close. Go ahead and plug it in. Maybe not the most beautiful, but it does check. Go ahead and plug that into your y equals. Y equals x cubed minus x squared. How do you come along the way? Yeah. Okay, if you do a little with Michael, you see that little higher one. So you guys are. No, negative. That's an equal sign. That's Robert E's coming in. So you can't see the double line? Really, like, really tight. I can understand why it's there, though. I'm like, can you drop that twice? Hey, does it have, probably not as deep as I have on my low point, huh? But once again, am I graphing exactly? No, I just got a good sketch. But did it go from 0 to -1? It did go below the x-axis, didn't it? Okay. And that was just me looking at end behavior, the zeros, and their multiplicities. And I got a pretty good sketch out of it. Okay. That's really what our goal is today. You know, we still have some time. Let's say, this is a good one. Okay, so this time, let's make this negative. That works fine. Negative 4x cubed plus 5x squared, blah, blah, blah. Okay. All right, once again, when we see fourth term and it's cubic, we only know how to find zeros currently one way. I believe in the next lesson or one of the next 2 lessons, we'll start showing you a different way to find zeros, okay? But right now, currently, this is the way we do it, okay? If it doesn't work like this, you guys are like, hey, I'm done, because I can't do anything. So we're going to factor by grouping. What does the front 2 have in common? What kind of an x squared? I guess we can leave it there, x squared. All right, awesome. What's left over? Negative 4x plus 5, because I did not pull out a negative, so I just pulled out the x squared. What do those guys have in common? A 3, not a negative 3, because if I did a negative 3, then they would be the same binomial. I want to pull out a positive 3, don't I? Is everybody there with me? Any questions there? I tell you, you just brought me back to April 1998. Miss Mia Fisher with that shirt again. Sadie, we probably call it Girls' Choice. Girls' Craft. I'd be an Adidas shirt just like that. Well, with long sleeves. Okay, let's find its zero, shall we? What's the value that makes this guy 0? We just set him equal to 0. I'd subtract the 5, divide by -4, so that comes out to be 5/4. What's his multiplicity? 1. Everybody understand why it's 1? Raised to the first power, right? With me on that? If I solved him, I get plus or minus I root 3. Are those zeros? Yes or no? Are they graphable zeros? If I was graphing it in the imaginary number line. Okay. So, What's the multiplicity on those though still? 2. Because each of them are their very own thing, aren't they? Isn't one of them x equals I root 3? X equals negative I root 3. So if I wrote them in linear factors, once again, this guy was negative, what was it? Is that what it was? Is that what it was? And then this guy was x minus I root 3, right? That's this guy. Once again, add it over. See how each of them have multiplicity of 1? Right? What do they add up to be? 3. Shouldn't it add up to be 3? Why? It was an x cubed, huh? So the most zeros I could have is how many? 3. And I have all of them. 2 of them are just imaginary. Right? Okay? So here we go. Let's find our 0. Our 0 is at 5/4. So roughly right here. But once again, I'm sketching. That's it. What's our end behavior? It's x cubed, wasn't it? So I have x cubed looking like this first off. But then what happens? Our leading coefficient was, so we go, ba-dam! We flip it! So we come from high and go to low. Let's try it. Coming from high. Not, yes. At that point, should I bounce or cross? Cross because I have an odd multiplicity. That is 5/4. Now, could there be some turning points in there that I don't have? Because once again, I could have 2 or 0. Currently, I have 0 turning points, correct? Okay. Camden, can you do me a favor and grab the one that's okay? Did it have, when you guys graphed it, anybody heard you graphing it? I'm just curious on what it looks like. Does not bounce whatsoever. Why would it not bounce? Odd multiplicity at that 0. But once again, they're not on the real number system, are they? I can't even graph this. Well, it could bounce somewhere down here, like this graph could look like this and still cross the 5/4, but I don't know that. Because once again, I'm just sketching with the end behavior and with, I still have one more example. I just want to make sure you guys get your homework so you can get out on time. By the way, you're doing only the odds. Okay? Let's do one I'm going to hurry and quickly make up. Here we go. Fun. Get my inner math nerd coming. Why not? Well, we're going to hide down there. Okay. Down there, you doing okay? Okay. Kind of saw that you were doing pretty well, hence why I asked you to do it for me. Okay. What is the degree? 8? No, senor. Here we go. We got 3 here. 2 here. That's 5. Plus another one. 6. Plus 8 more. 14. This is x to the 14th. So therefore, what is our end behavior as of right now? Up. Everybody with me on that? Okay, but what's its leading coefficient? Let's check. He's negative. He would come out positive, because 4x squared, something squared is positive. He's already positive. What about x to the 8th? He would come out positive. So I have a positive, 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 negative. Therefore, leading coefficient would be negative, going down. End behavior down. Ready? Positive, positive, positive times a negative gives me a negative. By the way, do I want to see this as a polynomial whatsoever? No. Really quick, stay for just 30 seconds. I'm going to hurry and show you. I have a 0. I have 1/4. I have negative 2/3. And I have 7. Okay, here we go. Really quick. End behavior. Starting down. Negative 2/3. I am crossing because of an odd multiplicity. At 0, I am crossing because of an odd multiplicity. At a 4th, I am bouncing and bouncing. Do I have the end behavior that's required? I do. Okay? Have a good one. Have a great weekend. Enjoy.